20D is about the binomial distribution. And I'm going to say this is extremely important. I guarantee you, you will see a question on your IB test from this section. Okay, so the first thing I want you to write down is everything in the blue box. So first of all, binomial, that indicates 2. A binomial experiment means there's, first of all, a fixed number of independent trials. There's an exact number of independent trials. There's only 2 possible results, hence binomial. It's either if something occurs, it's a success if one thing occurs, or a failure. It's either one or the other. There's nothing else that can happen. Like when you flip a coin, that's binomial because it's either heads or tails. There's nothing else that can happen in between. But the probability of success has to be the same for each trial. So if X is the number of successes, then P of X with n trials, each probability P, we say X is a binomial random variable. What I've seen on the mark scheme for these questions, even just recognizing, writing down the word binomial will get you 1 mark, automatic. If you just even recognize it's binomial, you're going to get a point. So that's how important this is. All right, we're going to do this the long way first, and then I'm going to show you an easier way. So looking back here, look at this spinner. This spinner up here is white for 1/4 of the time and blue for 3/4 of the time. So there's 2 results, 0 or 1, and X is the number of blue. So 0% or 0 blue would be white, which is 1/4 of the time probability. When it hits blue, the probability is 3/4. So what if we spin the spinner 3 times? 3 spins. So this is the chart I want you to write in the space in your notebook. And we're going to do a probability tree where you go up the tree to blue. So that probability is 3/4. You go down the tree to white. That probability is 1/4. Then you spin it again. Once again, you can either hit blue, which is 3/4, or white, which is 1/4. And you do that 3 times. So if I can either go blue, 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 white, or I can go white, blue, white, white, and then do it the 3rd time. So this represents the first spin, blue or white. This is the second spin. Then this is the 3rd spin. Do it 3 times. Then write the final outcome over here. If I follow the top tree, blue, 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 I get 3/4 times 3/4 times 3/4. That equivalent is 3/4 to the 3rd power. We look at the combination next. Blue, blue, white. Blue, blue, white is 3/4, 3/4 times 1/4. All right, and just kind of follow the pattern. If you need to stop the video to get all of this written down, that's fine. Now, I had you write this down because you do not want to do this every time. There is a much easier way to do this. Now, the first thing I want you to notice, this is the only way to get all 3 blue. There's only one way to do that. But notice these, this one, and this one, and this one, those 3 in the pink, there are 3 different ways that you can have 2 blues and 1 white. And their probability is the exact same. These, this one, and this one, all's where there's 2 blues, because blue is 3/4, 1 white. The order when I multiply these doesn't matter. So all 3 of those are the same. Then this yellow, this yellow, this yellow is where there's only 1 blue, but there's 2 white. and so forth. And then there's only one way to get all three white. So there's a whole lot easier way to do this. And I'm not going to have you worry about this. I'm going to have you remember something. Do you remember the last time we talked about binomial expansion? If you recall, chapter 1 started us off with binomials. So that's like we expanded x plus y squared. That's x plus y plus x plus y. And when it's squared, it's just nice and easy. You just distribute everything. You get x squared plus 2xy plus y squared. But when it starts getting up into the upper exponents, 3, 4, 5, and so forth, do you remember we talked about Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And what did the Pascal's triangle refer to? And this is a good review because you're going to have to know this. The 1, 2, 1 is the expansion. It's the coefficients of when you have it squared. If we have it to the third, we use this row where it would be 1, 3, 3, 1. And we take x to the highest exponent, x to the third, plus x goes down, x squared, y goes up, y1, plus 3, x goes down to 1, y goes up to 2, plus y to the third. I want you to think about there was one way to get x to the 0, or x equal to 0 with all white. That was 1 times 1/4 to the third. How did we get x equals to 1 where there's only one blue? There were 3, look back here, 3 ways to get one blue. 1 here, 2 here, 3 here. So we can simplify this process by finding that coefficient out front and then multiplying the probabilities times how many ways it can happen. All right? So think about this. I'm going to get rid of this part down here. And let me try and connect these dots a little better. So when the probability of x equals 0, that's no blue on the spinner, right? There's only one way it can happen. This is our first way. And no blues means we did 3 whites. White is 1/4, so it's 1/4 to the third. Now, when x is 1, that's where there's one blue. There are 3 ways that can happen, and there's one blue to the third with our power here. So we take the probability of 1 3/4 times white squared, 1/4 times 1/4. For x to be 2, that's where there's 2 blues. This is our coefficient, 3 here. And blue, if there's 2 blues, we have 3/4 times 3/4 times white, which is 1/4. For x to be 3, there's only one way for this to happen. And it's blue 3 times, so I have 3/4 times 3/4 times 3/4. This takes a little bit to absorb. All right, I'm not going to worry about this. This is kind of explaining. Oh, the one thing I will say, rather than Pascal's triangle, you might want to write that part down. We could just use our calculator to calculate that coefficient. That's way easier than doing Pascal's triangle, especially if it's to the 10th. You don't want to be going up that high. But let me show you how we do this. All right, so go ahead and copy this part down into your notes under a binomial distribution. So the probability of a little x is when the probability of our random variable equals x. This is our combination, NCR, n, this is n trials with x successes. The probability to this exponent, 1 minus the probability to the n minus x exponent. Okay, so now I think this is also helpful. That notation, you can either write binomial, you can also write it this way, and that's going to give you points as well. So pause the video for as long as you need to get this copied down before we do this last problem. Okay, so instead of x plus y in parentheses, it's the probabilities of each one. Notice 9/10 plus 1/10, those should always add up to 1. All right, so to expand it, now I'm going to actually just go back to Pascal for 5. 1, 1, 1, 2, 1. Remember, we just add these. 1 plus 2 is 3. 2 plus 1 is 3. 1. The outsides are always 1. The insides, we add the previous numbers up above it. To get that final list. Okay, so this exponent tells you want this row. All right, so first to expand it, and I'm not going to do the whole thing. We're just going to write out not the final answer, but just how it looks. All right, so our coefficient is 1. Then we use the first one, 9/10 to the highest exponent. And there's no 1/10. Plus, because this is plus here, everything will be plus. Move on to the next coefficient, 5. The 9/10 goes down from 5 to 4. The 1/10 starts to go up, so it's to the first. Remember, these exponents here should always add up to this beginning exponent. Plus, the next coefficient is 10. 9/10 goes down. 1/10 goes up, but they still must add up to 5. Plus, next coefficient is 10. 9/10 goes down to 2. 1/10 goes up to 3. All right, I'm going to have to go down to the next row here. Now I'm going to use the 5 as the coefficient. The 9/10 goes down to 1. The 1/10 goes up to 4. And our last coefficient is always going to be 1. Notice 9/10 was at 1. It goes down to 0. So I'm only left with 1/10 to the 5th. So that's all of letter A, is expanding all of that. All right. We don't have to find the final answer, but let's see how that relates to this word problem. Letter B says an archer has 90% chance of hitting a target with each arrow. So notice that 9/10 represents success 90% of the time. Okay. So the failure, 1/10, is your 10%, you're going to miss it. So notice it's binomial because they will either hit the target or they will not hit the target. That's why it's binomial. If 5 arrows are fired, the 5 arrows corresponds to the exponent 5. So this 5 is the number of trials. Determine the chance of hitting. This is exactly twice. So what that means, that's the 5 choose 2. So out of all of these, which one hits it twice? So think about this. This is hitting it all 5 times correctly. This is hitting it 4 times. This is hitting it 3 times. And even more than that, think about this is hitting it 5 times and not missing it once. This one hit 4 times, you miss once. Hit 3 times, miss twice. This one here represents what we're looking for. We hit it twice and we miss it 3 times. So this is our probability for BI. So we need to expand 10 times 9/10 squared times 1/10 to the third. All right, so let me show you how you can do this. This is just 10, right? 9 squared is 81. 1 squared is just 1. So we can just do all of the numerators over all of the denominators, but I have 10 squared and 10 to the third, so I have 10 to the fifth. So you can just plug all this into your calculator, but then I end up really with 81 over 10 to the fourth, which is just 81 over 10,000. So we can go 81, 1, 2, 3, 4. So that would be our percent. If you plugged it into your calculator, hopefully you got the same thing. All right, so for the last example, letter B is at most. So that means no more than 3. All right, so that means I'm going to take a different color. Not 5, not 4. It means this one, plus this one, plus this one, plus this one. So I'm going to give you a hint here. So remember that all probability will all add up to 1. If we added this whole thing, it would be equal to 1. See how I crossed out only 2? I don't want to figure out all 4 of these and add them together. That would be super annoying. So what we're going to do is I'm going to take 1 minus the first 2 because it's easier. So 1 times 9/10 to the fifth is just 9/10 to the fifth. I've got to add the first 2 together. 5 times 9/10 to the fourth times 1. So this is where I hit it 5 times. This one's where I hit it 4 times. And then I'm going to add those together, subtract it from 1. And I don't know what that is, but I know my final answer because I'm looking at the book. Is that. So there's going to be times where it's just easier, less work to take 1 minus what you can't do to get what you can do. And that's binomial distribution.